You just entered AshongLabs, the place to break down barriers and build up your cyber skills. What is going on, cyber warriors? Jason Ashong back with another video, and today we're on Try Hack Me's Advent of Cyber 2025, Day 5. IDOR, seen as Little IDOR. So in this room, we're going to be learning about IDOR, and we're going to help pen test the Try Present Me website. Let's start our attack box and start our target machine up real quick. So the elves of Wareville are on high alert since McSkitty went missing. Recently, the support team has been receiving many calls from parents who can't activate vouchers on the Try Present Me website. They also mentioned they are receiving many targeted phishing emails containing information that is not public. The support team is wary and has enlisted the help of the Best Festival Company staff. When looking into this peculiar case, they discovered a suspiciously named account named Sir Carrotbane, which has many vouchers assigned to it. For now, they've deleted the account and retrieved the vouchers, but something's going on. Can you help the Best Festival staff investigate the Try Present Me website and fix the vulnerabilities? The learning objectives of this room are going to be understanding the concept of authentication as well as authorization, learn how to spot potential opportunities for insecure direct object references, IDORs, exploit IDOR to perform horizontal privilege escalation, learn how to turn IDOR into SDOR, secure direct object reference. So let's connect to your machines if you haven't already and check this box. I'm going to open this in full screen, close this real quick while I start up reading task 2. It's dangerously obvious, really. Have you ever seen a link that looks like this? Awesome.website.tryhackme. This track package and then the package ID equals 1001. When you saw a link like this, have you ever wondered what would happen if you changed the package ID from 1001 to, let's say, 11 or 12? In its simplest form, this could be a potential case for IDOR. IDOR stands for Insecure Direct Object Reference, and it's a type of access control vulnerability. Web applications often use references to determine what data to return when you make a request, but if the web server isn't performing a check to see if you are who you say you are, then you can leak sensitive information. So to understand why this happens so often, you need to understand references as well as web development a little bit. So let's take a look at what a table storing these package numbers from our link example could look like. So we have 4 columns: package ID, person, address, and status. Package ID is basically the user IDs of each of these people. So a person has a unique package ID, they have an address, and then they also have a status: delivered, in transit, out for delivery, pending, or returned. If you want to know the status of your package, you're going to make a web request, and then it's going to ask you to put your package ID in. And then when you put in your package ID, the website is going to get from the database the status of your delivery. The query that is being sent to the website is this. So it's going to select the person, Alice Smith. It's going to select your address, and then it's going to get your status from packages. Your package is what this table is. And then where package ID equals 1001. So basically it's saying that it's going to get all the information from whichever package ID is being equaled here. And so whichever one is the value. However, since package ID is a sequential number, it becomes pretty obvious to guess package IDs of other customers. 1005 is Eve Martinez, and then you go back a couple times, you get Carol White 1003. That's a problem. To dive a bit deeper, we need to understand authentication, authorization, and privilege escalation. And then right here, they have a note from one of the co-authors of this task. I'm not going to read this because it could get a little confusing, but if anybody is interested, you should read what they have to say right here. Identity defines our reach. To understand the root cause of IDOR, we need to understand the basic principles of authentication and authorization. Authentication is basically verifying who you say you are. Like, hey, I say my name is Jason. I'm trying to log into this website, so I'm going to enter my password as well as my username. And now I'm authenticated. Authorization is saying that you're able to access what you're trying to access. Am I allowed to visit the admin page of a web application, or am I only allowed to make a payment using a specific account? That's what authorization is. Am I authorized to do this or not? And this says that authentication only happens once. Basically, you're when you're using a website, you have a session. You have like an active session that has cookies, it has tokens, and then all of this is attached to your session, your current session. So verification is always happening anytime you try to access something on a website. If you were logged in, let's say you stay idle on a page for too long and then you refresh and it re-prompts you to log in. That is because your cookie or your session token is invalid now and it just it expired basically. So you have to re-authenticate. And then the last part, they're talking a bit about privilege escalation types. You have vertical privilege escalation, which is basically when a user gets more access than they're allowed to get. Basically, when you move from like let's say a standard level user account to an admin account, that is vertical privilege escalation. I don't know why I keep saying that. Escalation. And then we have horizontal privilege escalation. This refers to privilege escalation, where when you use a feature you're authorized to use, but then you gain access to data that you're not allowed to see. So basically, it's let's say there's like 5 standard accounts, and I'm on one standard account. If I'm able to get to the other standard account, that's horizontal privilege escalation. And IDOR is usually a form of horizontal privilege escalation. Now we have our username and password, and then our IP address. So let's go to the website and see what they got for us. Let's open up Firefox. So now that Firefox is open, let's browse to our IP address, and then let's sign in using the credentials that were given to us. Niels was the username. Try hack me. Hashtag 2025 is the password. All right, now we are on our page, our website that we're going to be hacking. Pen testing. So let's start by using the developer tools of our browser to better understand what's happening. So you right click with your mouse, and then you go to inspect elements, and then we're going to be using the network tab, I believe, for this. When you're on the website, you reload. So these are the requests that are being made on this website, and then we're going to take a closer look at the view account info request. So we're going to click on it and then go to response, and then this is going to give us a bunch of data. So right here, the user account Niels that we just logged into, his user ID is equal to 10. And then this is some more data about Niels. So this tells us that the application is using our user ID as the reference for getting details. So let's see what happens when we change this. Go to storage, the storage tab, and then local storage, and click the URL inside of it. So storage, local storage on the bottom left, and then click the URL. And then we are going to be changing our user ID to 11. Let's see what happens. So right now we are at niels@webmail.tryhackme. Change this to 11, hit enter, and then refresh the page. Now we have the user, now we're into the account test@test.com. We're still logged in as Niels, but we're on a different page. And this page is not our page. So to continue on to the next challenges of this task, go back and change the user ID back to 10. So let's do what we basically just did. Storage, local storage. And then change this back to 10. Alrighty, let me zoom out a little bit so it's a little easier to see. Sometimes IDOR may not be as simple as just a number. In certain cases, encoding may have been used. On the loaded profile, click the eye icon next to the first child as shown on the image below. And then go to the network tab and look at the request being made. You should see a request like this. Got it. So I'll hit the eye icon right here. And then you just saw these things load up. And then this is the request that was just made right here. MG equals. So MG equals is the Base64 encoded version of the number 2. And it's basically telling us we can still use IDOR, but you would have to base64 encode the number first. So if you want to see this in real time, let's go back to our attack box. Right here in the Firefox, it has an offline CyberChef that we can use. CyberChef is a wonderful tool we can use for encoding and decoding. Let's see what we can do real quick. So from base64, because our thing is already in base64, we can type equals mg equals. Nope, I'm a liar. Oh, it's lowercase g. mg equals. So then the output is giving us 2. So basically it's telling us that from 2, if you want to encode it to base64, is going to give you this. And then if you want to decode it from base64 to decimal, it's going to give you the number 2. Now let's go to our next topic. In digest, objects remain. Encoding isn't the only thing that can be used to hide potential IDOR vulnerabilities. Sometimes the values may look like a hash, such as MD5 or SHA-1. If you want to see what it would look like, take a look at the request that happens when you click the edit icon next to a child. Go back here. Keep this open, and then so instead of hitting the eye icon, we're going to hit edit. So this just came up right here. This is some type of hash. Hovering over it, I think it says it's MD5. But if we didn't know that, we can use this tool right here, hash identifier. Let's open this right here. Let's copy this hash. That's not it. Let's copy this real quick and see what type of hash it is. So now it's telling us that the possible hash that it is MD5. The next topic is deterministic, obviously reproducible. Sometimes you have to dig quite deep for IDOR. Sometimes IDOR is not as clear because it stems from the actual algorithm being used. In this last case, let's take a look at our vouchers. While the values may look random, we need to investigate what algorithm was used to generate them. Their format looks like a UUID. So let's use a UUID decoder to try to understand what format was used. Copy one of the vouchers to the website for decoding. So let's click that real quick, and then on our website, let's close this real quick, and then copy one of the vouchers. Let's paste that in here and then decode UUID. Now this is giving us the information on the UUID, the version that it's using, and then this is the date that it was generated, and then it's just some more information. So while the UUID looks completely random, you can see what version was used, as I pointed out, version 1. And the problem with that is that it tells us the exact date that the code was generated, so you can recover it. For example, suppose we knew that the L is always generated vouchers between 8 o'clock to 9 o'clock. In that case, we can create UUIDs for that entire time period, 3,600 UUIDs, since we have 60 minutes and 60 seconds. Since we have 60 minutes, and then there's 60 seconds in a minute. So we can use that in a brute force attack to try to reclaim a valid voucher and get more gifts. Now that we have seen the various IDORs that can be found, let's discuss how to avoid them and fix them. Improve design, obliterate risk. That's another player in the acronym IDOR. Now that we learned about what IDOR is, let's discuss how to fix it. The best way to stop IDOR is to make sure the server checks who's asking for the data every single time. It's not enough to hide or change the ID number. The system must confirm that the user logged in is authorized to see or change that information. And that makes sense, because I shouldn't be able to access something if I haven't said that I am the person that's supposed to access it. as I was showing you guys here, I was logged into Neil's, but we were on the test account. It was telling us email equals test@test.com, an obvious thing right there that's showing us that it's not checking to see who's supposed to be logged in. Don't rely on tricks like Base64 or hashing the IDs. Those can still easily be guessed or decoded. You're supposed to keep all the real permission checks on the server. When a request comes in, check it on the server. Does this user own or have permission to view this item? And you should also use random or hard to guess IDs for public links. But remember, IDs alone don't make your app safe. You should always test your app by trying to open another user's data and making sure it's blocked. Finally, record and monitor failed access attempts, because they could be an early sign of someone trying to exploit an IDOR. That's why logs are really important. And now let's get to our flags. What does IDOR stand for? Insecure Direct Object Reference. I hope you guys typed that faster than I did. What type of privilege escalation are most IDOR cases? As I was explaining, there's two. There's vertical and horizontal. Horizontal is the one that usually is going to be in IDOR cases because you're viewing other standard users' accounts. Exploiting the IDOR found in the view accounts parameter. What is the user ID of the parent that has 10 children? So the view accounts was the first one that we did that gave us the test. So let's go back to inspect elements, network, and reload. So now let's go to storage, local storage, refresh it if you have to. I just had to real quick. And then let's type in, so we already tried 12. We already tried 11. Let's try 12. And then refresh the page and see what we get. So this user has no children. This is also a test account. But we're going to try 13 and see what we get there. So I just got logged out. I don't know what I did, but we're back. So we just tried 12. 12 didn't work, so let's try 13. Refresh the page. Bad Bunny dot try hack me. This has nothing for us. So now let us try 14. Please, 14, have something for us. Have at least 10 children. 14 has 2 children only. So we're going to try 15. And we're just iterating through all of the possible IDs that could possibly be valid. And look, we found the valid ID. So this user has 6, 9, 10. So this user right here has 10 children, and that is what we were just looking for. So this flag is 15. Bonus task. If you want to dive even deeper, use either the Base64 or MD5 child endpoint and try to find the ID number of the child born on April 17th, 2019. To make iteration faster, consider using something like BurpSuite Intruder. If you want to check your answer, click on the hint question. Alright. Now we're going to open up BurpSuite. So once BurpSuite opens, we're going to want to click next and start burp. And then let's go back to our Firefox browser and then turn Foxy Proxy on. All right, and now BurpSuite is open. Let's close out of that, and then let's go to our proxy tab and make sure intercept is turned on. Go to Firefox, and then all right. So now let's get some child information. So we're gonna reload this page real quick. You see these glowing right here? That means BurpSuite is capturing our packet. Let's forward that so we can get to the page. Forward. And now let's click on view details on one of the children. And then let's go back to BurpSuite to see what it captured. All right, so this is the traffic that it captured from child Thistle right here. So this is the request, this get request. And then right here, we are seeing that it's Base64 MTE equals. All right, so if we want to go, let's say we want to go to our cyber chef real quick and see what number this is. MCE equals gives us 11. So our child ID for this guy is 11. So this is our Base64 encoded child ID. Now let's send this to Intruder so we can do some more fun stuff. So now that we have a response in Intruder, we're going to want to start doing some hacking. So we're gonna highlight our Base64 encoded string, and then we're gonna click add right here. And then this is going to let us put in our payload. And we're also going to want to create a payload that's going to have the different child ID numbers. So I'm using Brave browser. I'm going to say in the AI right here, I'm going to ask it to generate me Base64 versions of the numbers 12 through 20. Because we have 11 and we know that there's 10 children, so I'm going to do from 12 to 20. See, this is one of the struggles of using AI. All right, so we got our Base64 encoded. Let's go to our terminal real quick. Nano payload text. Let's hit Control X, Control Y to save and exit, and then let's ls just to see where it is. So it's on our root directory. Payload.txt. Awesome. Now let's go back to BurpSuite. Click load. Right here you see payload.txt, so we can hit open, and then that is going to put all of our values right here. So now that the list is generated and we have the payload there, we are going to click start attack. Now what it should, beautiful. So now we're getting responses back, generating status code 200s, which means that the web server responded to our request. Then we are going to view our responses. We hit the response tab, and we're going to go through every single one of these. So the first one, child ID 12, is Bramble. He was born 2013, November 22nd, 2013. Nope. 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 Willow. Okay. This one is April 17th, 2019. I think that's what we're looking for right here. Which child was born April 4th or April 17th, 2019? All right, so I think we got the answer. So let's hit the light bulb to see what the answer is. Answer 19, child ID is equal to 19. Awesome, guys. Good job right there. And now we are going to go even further. So using the parents' vouchers claim endpoint, find the voucher that is valid on November 20th, 2025. Insider information tells you that the voucher was generated exactly on the minute somewhere between 8 o'clock to 12 o'clock UTC that day. What is the voucher code? If you want to check your answer, click on the hint on the question. All right, so let's go back here. Let's go to our... Turn this off real quick. Close out of this. We don't need this attack. And then let's turn intercept off. Then Foxy Proxy, let's also turn that off. Disable it. Now let's go to this URL that they told us to. All right, so Sir breeds a lot at 10children.tryhackme. Still logged in as Niels. So this goes back to the UUID thing that they were talking about earlier, right here. So going back to this was telling us what the problem with the UUIDs version 1 was, and it was that if we know the time that the vouchers were generated, then we could kind of go back and brute force our way into figuring out which times go to which vouchers. And I'll give like a little analogy kind of explaining this with a little Christmas theme. And I'll give a little analogy explaining this Christmas theme. So let's say Santa prints gift coupons every single minute from 8 o'clock p.m. to midnight. The coupon numbers are just the minute timestamp that are kind of like encoded, but the pattern never changes. So at 8 o'clock, I'm making this exact coupon. And then at 8:01, I'm making this exact coupon. The numbers are going to match every single time because of it's using version 1. It's going to be using the same algorithm. I hope I explained that well. Let's just get to hacking. So it's not really practical for me to go through and generate each of these vouchers, but we do have this paste bin from David Ackerman, and this is going to give us. So let's go back to terminal and then do pay2.txt, payload 2, and then we'll paste in our vouchers. Now we save that, Control X, Control Y, enter to save that to our root directory, and then let's go back to BurpSuite, turn intercept back on, and then go back to Firefox as well, and then turn Foxy Proxy back on. And now we are going to try to claim a voucher. We're going to put, let's say, this, and BurpSuite caught that post, that request, and then we're going to send this to Intruder. So right here, what's labeled in green is our input. So we're going to copy this. I don't know if we copy the whole. Yeah, I think we do. Copy this and then add the payload here. And then we are going to load this from pay2.txt because this is the payload that we just generated with all the vouchers. And now we're going to start our attack and let's see what we get. Click OK. Now we're getting a bunch of status 402, 422s, 404s. Eventually, I'm hoping to see some status 200s, which means valid. Oh, maybe I think syntax error, syntax. So I think I wasn't supposed to go over the quotations. Now let's start this attack like this. Now we're getting status 404s. So the reason why I thought that something was wrong after we're getting the status 422s is because status 422 is like what you get in response to the server not being able to process a request. I was like, okay, maybe we typed something in wrong. But if we typed, like, let's say we typed in a wrong password, we would still get a status 404. It would just say voucher not found right here. See, I was going to say the other payload, it was the 422s. It would have said it probably would have said this server can't process your request or something like that. But status code 404 is voucher not found, and right here we see status code 200, which means the code is found. So my mic had died when I was recording, so now I'm re-recording this part. But what I was saying was we're getting status code 200 from this specific payload, which means that this voucher code is valid because right here we're getting a created at date, which is October 10th, 2025. And status code 200 basically means that we're getting an okay response back from the server. All these status code 404 are like error not found. And then we're seeing the details right here. It says voucher not found. But this one, it says status code 200, and then it found the code. So let's go back to our hint, and then let's click this to see if it matches. Sorry, that's the wrong one. 2264300, and that is exactly what our code is. So we got the code, guys. Good job. Thank you guys for joining me today. I hope you enjoyed this walkthrough. If you did, please be sure to leave a like, comment, and subscribe so you can keep up to date with more new content coming very soon.